We'll start with unit number 3. Laws of motion. That's chapter number 5 of NCERT. See introduction, like what will you study in laws of motion? See, this laws of motion, it's a part of dynamics. Dynamics is basically that branch of physics which deals with the cause of motion. We will study cause of motion here. Why a motion occurs. We will study cause of motion. And the cause of motion is force. We'll basically study about force. So to study this force, we will study Newton's laws. That's why this is laws of motion. So up to last chapter, chapter number 4, motion in 1D, motion in 2D, we studied motion of a body. But in this chapter, we will study the cause of motion. Okay, Fatima, no issue. So in this chapter, we'll study the cause of motion. The cause of motion is force. Up to chapter number 4, we have studied about motion, that if a body is moving, it will cover some displacement, it will have some velocity. But that was not the cause of motion. Here we will study the cause of motion, why motion happens in first place. If a body is at rest, it will not come into motion by on its own. You will need some external agency that will take this body from rest to motion. And that external agency is force. We'll study about force. So this laws of motion starts with the concept of inertia. So inertia is basically the inability of a body to change its state. Inertia is basically the inability of body to change its state. To change its state of rest or of uniform motion. Means if a body is at rest, it cannot comes in motion on its own. If a body is at motion, it cannot come at rest on its own. It will always try to maintain its state. Means a body at rest will try to remain at rest always. Body in motion will try to remain in motion always. This property of body is known as inertia. We have 3 types of inertia that we will study in detail in Newton's first law. We have 3 types of inertia: inertia of rest, then this is inertia of motion, and the third one is inertia of direction. Third one is inertia of direction. So inertia of rest means inability of body to change its state of rest. It's inability of body to change its state of rest. Inertia of motion means inability of body to change its state of motion. And the third one is inability to change its state of direction. Inability of body to change its state of direction, to change its direction. By itself. By itself. By itself. So to change state of rest or motion or direction, body needs some external push, and that external push is force. Basically, this concept of inertia was introduced by Galileo. This was introduced by Galileo. And this concept of inertia leads to Newton's laws of motion, and eventually to the concept of force. The next is Newton's first law. Now, this Newton's first law is related to the concept of inertia. Newton's first law. So the Newton's first law defines force. It defines what is force. Newton's first law defines force. So Newton's first law says force is an external agent that can change the inertia of a body. Says that force is an external agent in the form of push or pull, in the form of push. Sure, Fatma. Okay. Push or pull that can change inertia of body. So it's an external agent which is in the form of a push that can easily change the inertia of a body. So this is the definition of force. So force is an external agent which can change the inertia. Let's see some examples. We will see examples of types of inertia separately. So if we consider type of inertia, the first inertia is inertia of rest. See first example for inertia of rest. In this example, you will see that a body tries to maintain its state of rest. See, this is a man. He's standing on the floor, and this bus is at rest. The driver switched on the engine, and this bus starts moving in this direction. See, a force, the engine applies a force F on the bus, due to which this bus starts moving. So initially, bus was at rest. So this bus, these tires, and the man standing on the bus will try to maintain their inertia of rest. So everyone, this man, this tire, and everything will try to maintain its inertia of rest. So as soon as the engine apply force on the bus comes in motion, means bus overcome its inertia of rest due to this external force. That force also acts on this man standing on the bus. He comes in motion along with the bus. but the upper part, no force is directly acting on the upper part of the body. So this upper part will try to maintain its inertia of rest. It will try to remain at rest. The lower part move in the forward direction, but this upper part try to maintain its inertia of rest. So what happened? This upper part will experience a backward push due to inertia. This is what happens if you're sitting in a car. As soon as the car starts, the body within the car will experience a backward push. If you're sitting in a car, you will experience a backward push as soon as the car starts. So that backward push is due to inertia of rest. I'm explaining it again. Initially, the car was at rest. As soon as you apply the force over the car, the feet of the man comes in motion along with the car. But the upper part, no force is directly acting over the upper part. So the upper part will try to maintain its inertia of rest. So the upper part comes at rest, the lower part comes in motion. So this man will experience a backward push. This is an example of inertia of rest. Just like inertia of rest, not just car, in any example where initially your body was at rest and then it comes in motion, the body will experience a backward push, and that backward push is due to, this is an example of inertia of rest. The next is inertia of motion. The next example is that of inertia of motion. So initially this car was in motion, or this bus was in motion. There's a person standing on the bus. This bus will try to maintain its inertia of motion. This man will try to maintain its inertia of motion in this direction. So if the bus is moving with a velocity of 100 km per hour, then man is within the bus. He is moving with respect to ground with a velocity of 100 km per hour. But as soon as you apply brakes on the car, so you applied some external force to overcome the inertia of the car. What's the initial inertia of the car, Sanya? Is it inertia of rest or inertia of motion in the car?
Inertia of motion.
Inertia of motion. And that of man? Inertia of motion.
Of motion.
So when the driver applies brake on the car, he's applying some external force over the car. That force will force this car to come at rest, to overcome its inertia of motion. That force through the floor of the bus is acting on the feet of the man. So the feet will experience the same force and comes at rest. But this upper part of the body, there is no direct force over the upper part of the body. So this upper part of the body will try to maintain its inertia of motion. This will try to move at the speed of 100 km per hour. So what happens? The lower part of the body comes at rest, but the upper part try to move in the same direction. So due to this, this upper part will experience a forward push. This is what happens when a car moving with a very high velocity suddenly stops, we will experience a forward push. That's why you have seat belts in the car. So this is example of inertia of motion. Then you have one more example, that is inertia of direction. One more example of inertia of direction. Inertia of direction. This simply says that a body cannot change its direction by itself. The natural tendency of a body is to move in a straight line. Let's see the example of inertia of direction. So what is the natural tendency of a body? To remain at rest or move in a, to move in a straight line, or it can change its direction by itself?
Change its direction.
The natural tendency of body to move is not to change its direction. If a body does not change its direction, that way it will move in a straight line. So the natural tendency of a body is to move in a straight line. So this is the natural tendency of a body to move in a straight line. So body will not change its direction on its own. It will move in a straight line. To change direction, some external force needed to be applied. External force need to be applied. See, example. So I take a string, I connected a stone with this string, and I'm revolving this stone on a circular path. This is revolving in this one, a circular path. To revolve this string, I'm applying some force through my hand. I'm applying a continuous force through my hand. That's why the direction of velocity is changing. See, if this stone is moving in this way, it's revolving around. If it is the hand, the stone is revolving around the hand. That means the direction of its velocity is continuously changing. To continuously change the direction of velocity, I have to apply some force through my hand. Let's assume if this string breaks in midway, somewhere. Over this point, the string breaks. Now, Sania, can this stone change the direction of its velocity now?
Yes, sir. If we apply.
But the string breaks. I'm applying force over the stone through my hand with this and through the string. If the string breaks in over this point,
No, it will not break.
then how will it go? It will move. It will continue to move in the circular path, or it will go tangential.
It will continue moving circular path.
Circular path. String breaks. If a string breaks, then the external force which was changing the direction of velocity of the string will not be there. So there was
Okay.
external factor which can change the velocity. So its velocity will not change. It will move
It will
in a straight line. That means it will go tangential.
change.
So as soon as the string breaks, as soon as the string breaks, mass will go tangential. Because its natural tendency was to move in a straight line. To move it on a circular track, I was applying some force through my hand. So once the string breaks, that force withdraws and it can't move on the circular track, so it moves in a straight line. So this was example of inertia of direction. There are plenty of examples, like if a car is moving on a circular track, whenever it takes a sharp turn, you feel a force which is in the outwards direction. The reason is same. Some basics of graph. So this is x-axis. This one is y-axis. If you have an equation of this form, y is proportional to x. The power of x is 1, the power of y is 1. This is known as linear equation. This equation is linear. If your equation is linear, then graph is a straight line. If your equation is linear, then graph is a straight line. So for linear equation, graph is always a straight line. But if your equation is in this form, y is inversely proportional to x. That means if I'm increasing x, then y will decrease. So this is a straight line graph for linear equation. But for these type of equations, if it's 1 by x, or it could be 1 by x square, or it could be 1 by x cube, or it could be any power of x. In this type of equations, if you are increasing x, then your y will decrease. The graph cannot be a straight line. Your graph will have this form. We call this as hyperbolic graph. Hyperbola. This will be the shape of the graph. If your equation is of the form 1 by x or 1 by x square or 1 by x cube. And this is one more thing, that is slope of the graph. So if this is x and this is y, and this is this equation, this is the graph, this angle is theta, then the slope of the graph is tan theta. Tangent of angle theta is the slope of the graph. Slope always means tangent tan of angle theta, the angle theta which the line makes with the x-axis. I will use these topics in these concepts in the next topic. Just note it down. Okay, the next thing is momentum. After Newton's first law, Newton gave second law, but for second law, he used the concept of momentum. So it's important to know momentum to understand Newton's second law. So momentum is simply the amount of motion in a body. It's simply the amount of motion in a body. The amount of motion in a body is momentum. So if you have a body of mass, it's moving with a velocity v. So the momentum is represented by p, which is the product of mass and velocity of the body. This is momentum. The product of mass and velocity. It's a vector quantity. Its SI unit is kg meter per second. Direction is same as that of velocity. Same as velocity. So this is it. P is equal to mv. Now, there are few conceptual questions based on graph using the concept of momentum. So if I take m equal to constant, then this momentum is directly proportional to velocity. If mass of the body is constant, then momentum is directly proportional to velocity. The nature of graph, can you guess the nature of graph now?
Straight line.
They are directly proportional, so the nature of graph will be straight line. In the same, P is equal to mv. If I write v is equal to constant, v equal to constant means momentum is directly proportional to mass. Now, can you guess the nature of graph now? This is mass and this is momentum. This is again directly proportional. Your graph will be a straight line. But if I say that momentum is constant, you have to plot P versus V graph. If I say that P equal to constant, means your M is equal to P by V. Your M is inversely proportional to V. Sania, what would be the shape of the graph now? It's inversely proportional. Like if I'm increasing V, this M will decrease. So the shape of the graph, if I'm taking V here and M here, then the graph will be parabolic.
Yeah, this.
Or
Yeah.
increase V, then M will decrease. This would be the shape of the graph. Clear?
Yeah.
We just noted now. Okay, solve this question. A body of mass 10 kg starts from rest and accelerate at 10 meter per second square. Calculate its velocity, not velocity, its momentum after 5 seconds. Solve it. Calculate its momentum after 5 seconds. It's a simple problem. First, calculate the velocity of the body after 5 seconds. It's an easy problem. The initial velocity is 0. The mass of the body is 10 kg. The acceleration is 10 meter per second square. You need momentum after 10 seconds. So for momentum, you first calculate velocity using this relation v is u plus at. U is 0, a is 10, t is 10, velocity is 100 meter per second. This is velocity 100 meter per second. So once you have velocity, sorry, after 5 seconds, sorry. Time is 5. So I put t equal to 5, so that's 50 meter per second. So the momentum is mv, your mass is 10 kg, your velocity is 50, so that is 500 kg meter per second.